Hi, and welcome to our second session of the Grade 5 Set 2 course. So we've got a little recap. This grows massively through the course because what we do at the beginning of every session is we do a little bit of revision on all our previous learning, and that regular going over of the same topics over and over and over makes such a massive difference to our memory recall and our confidence in being able to just retrieve that information and know what method to use where, etc., etc. So at the moment it's looking a little bit small, but trust me, it fills the entire page by the time we're even halfway through. So there's 4 questions based on what we did last session. I'd like you to hit pause and press play when you are ready. Okay, so the answers to those, I've done the first 2, and then I thought I would just go through 3 and 4 quickly, just because they are a little bit trickier. And if you were struggling with those practice questions last time, it might be nice to just see it unfold and be modelled to you. So we will do that quickly now. So what I'll do is I'll clean off those so that I've got a bit of room, and then I can work on both of them. So I've got t equals x divided by 2 plus 4. The last thing I said was plus 4. Bidmus backwards would tell me to move the add first. So I'm going to be picking this up, dropping it on the other side, where it's going to land as minus 4. T is already there. Minus 4 lands, and that is equaling x over 2. Now that over is a natural way to look at that and maybe say that, but we've got to remember it is a divide. So I'm going to be getting rid of the 2 next, picking up that divide by 2, and it's going to drop and land as times 2. Okay, and this is the question where you could possibly leave it in a bracket form. So you could say I've got all of t minus 4 needing to be multiplied by 2, because that is one way to represent the x, or you could physically multiply them out, and then that would give you 2t minus 8 equaling x. And as I say, they're equivalent to each other, and for that reason they would be accepted either or. You would get those marks. Okay, so the next question, y equals 4 minus x squared. Now there's absolutely no point in doing anything with that x at this stage. We've got a positive number here, and we've got a power here. We've also got a negative, which we're going to be looking at and seeing what that's all about. So my positive 4 is going, first of all, it's going to land as negative 4, which would in turn create that subtraction of minus 4. Don't lose that minus, it's still there with the x squared. Okay. Now, this is where it's not as easy to see what's going on. So what I'm going to do is I'm just going to include the number 1, which is invisible, which we don't show. I've got 1x squared. In fact, I've got minus 1x squared. So this minus 1 is actually negative 1 being multiplied to the x. So this means minus 1 times x squared. We might as well rewrite that side as well. So what I'm actually doing is picking up the times with the negative 1, bringing it across, and it's going to land as divide. I've got to divide everything that's there, and I'm going to divide by minus 1. Okay. So this is where, like I say, it gets complicated, and this is really bordering onto higher, more than foundation. I don't think I've seen anything this hard on a foundation paper, but you may be joining me with a view of studying higher. So it's really important that we touch on these things as well. So if I have a number, now I'm going to do this by numbers to start off with so that it makes sense. If I have 5 and I have to divide that by -1, how many ones can I get into 5? So how many ones can I get into 5? Yeah, it's 5. And then how many negatives can I see? I can see 1 negative, so there's 1 in the answer. So what's actually happening is my +5, when it gets divided by -1, turns to -5. So that's what's going to happen over here. My +y, because it's being divided by -1, will turn into -y. My -4, because it's being divided by -1, will turn into +4. 2 negatives make a positive. So these signs are getting switched around due to that negative. Okay, so I've got -y plus 4 equaling x squared. Last thing to do is to bring that power across and it will land as a root. So x is equal to the square root of -y plus 4. I could also start with the positive and write -y. Again, it's all fine. Now, if you are finding that hard, it is. I'm not going to lie to you. That is a tricky concept and a lot of maths going on there. We don't generally see rearranging formula that tricky on a foundation paper, but we certainly need to be aware of all of that if we are studying higher GCSE. So important for us to be making clear where your study needs to be depending on where you are, okay? So that is our rearranging recap. We are now moving on to simultaneous equations. Now, simultaneous equations are another big topic that can easily get muddled and confused. So we're going to separate this into 2 sections. I'm going to show you how to do simultaneous equations where everything is positive. So I don't have to think about negative numbers in my process. That gives me the opportunity to learn the method and secure that method so that when the negatives come in, I'm kind of ready for it. My brain can take on that little bit of extra information because it's already feeling comfortable with the method. So that's why we're seeing it in 2 parts. I'm not going to chuck everything at you all at once. We're going to master our method using positive terms. We'll see what I mean by that in a moment. And then next session, you'll see us advancing into those negatives. So let's go through this. So we're going to look at 4x plus y equals 11 and 3x plus 2y equals 12. Now, there is one value for x and one value for y that is going to work in both those equations to give the answers that we have. So one value of x will give us 11 with the y, and vice versa, okay? So it's not a multitude of answers. We call them simultaneous equations because we are going to simultaneously, within our method, work out both the x and the y values. But actually we do cheat and we get rid of one of them so we can just concentrate on the other. And we do this using the elimination method. So we're eliminating one to concentrate on the other. Now, there's lots of different ways that you can approach the pairing stage, which is the very first stage. Now, I personally, no matter what is happening in the middle, I don't even look at the middle. I always look at my first set of variables. My variables are x. They don't have to be. They commonly are. Most of what we're going to do will be x's at the beginning, but it's not about the x. It's just about the beginning. And what I want to do as my first step is get these so that they are the same number. At the moment, they are different. They are 4 and 3. I want to get them the same. So to do that, I'm going to cross multiply them. if I times the top one by 3, 4 times 3 is going to give me 12. If I multiply the bottom one by 4, 3 times 4 is going to give me 12. So by just crossing these over like that, I can get them to match. But what I must be aware of at this stage is that I don't just multiply the 3 to the 4. I have to multiply the 3 to the y and to the 11. I have to multiply it to everything in the equation. So if I do that, 4x times 3 is 12x, y times 3 is 3y, and 11 times 3 is 33. I'm then going to do the same along the bottom. So 4 times 3 is 12x. This is perfect. This is what we want to see. We want to see that beginning to look the same. I've then got 4 times 2, which is 8y, equaling 4 times 12, which is 48. Okay. So that's my first step done. So if you're making the notes, you're going to write down step 1, get the first terms the same. All right, and that is what we have just done. The second step, step 2, is to take away. Now, I'm going to draw a little line like I'm doing column subtraction, and I'm going to do every single part of the equation in turn, okay? So I am going to get my little highlighter. I'm going to do 12, take 12. I've got 12 x's and I'm going to take 12 x's away. If I do that, I'm going to end up with 0, no x's. They have been eliminated. And that is what we want to do. We want the x's to just be gone so we can concentrate on the y's. So they have gone. So now I'm looking at my y's. Now, one of my top tips here, because when we get into negatives, it starts to get a little confusing, and that's when we can see things going wrong. So to try and help us, we are going to show the takeaway that we do. So 12, take 12, it's gone. I am at positive 3, and I'm going to take away 8. 3 take 8 is minus 5y. So I've got minus 5y happening there. And then I'm going to do 33, take away the 48, which is going to give me minus 15. Now, if I want to know what y equals, I have to get it on its own. So I'm now going to go back to my standard equation method. All right, now throughout our courses, you will see us using the hopping method. So I'm going to be using that here. So if I want y on its own, I'm going to pick up that times by negative 5. So let's pick that up. I'm going to pick up my times negative 5. It's going to land as divide negative 5. And how many 5s can I get into 15? Y is now on its own. 5s into 15 go 3. And the 2 negatives make it positive. So it is y equals 3. So not only have I done step 2, the take away, I've also gone on to solve for y. So step 2 is take away and solve. And you will always get that. Now, I am going to show you something that may be useful. If you are someone that really doesn't get on very well with negatives, and you're really just trying to challenge and stretch yourself with this kind of work, one of the things that you can do is rearrange the position of the two equations. So what I could have done was I could have said, right, I'm looking at this and I can see that that's going to go into a minus number, and I want to avoid that if I can. So what I'll do is I'll write 12x plus 8y equals 48. I'll stick that one on the top, and then I'll put the other one, 12x plus 3y equaling 33, underneath it. This is perfectly fine. I would then do my take away, take away, take away. And actually what I get is 8 take 3, 5y, 48 take 33, 15. Divide through by the 5, and your y is equal to 3. Exactly the same thing without the negatives. I'd love to tell you that that would work every single time, but it doesn't. It just works sometimes. Sometimes you can rearrange it and it'll work with one section of the question, but then it won't work with another section of the question. It's working beautifully here. And it's a nice little trick to have up your sleeve if you were struggling, but it would be better if you could just go with what appears. And if you've got some negatives coming, they're going to happen. We just work with them and we just try not to let them put us off. That is just a little, might be worth knowing extra, okay? All right, so we've done step 1, we've done step 2. What we now want to do is use our answer to help us find x. Because if I know what y is equal to, I don't really need to use y in the equation anymore. So what I do is I go back up to my original question, I take a look at both of them, and I just decide which one I think would be the easiest one to work with. I like the top one because there's just a single y there. So for that reason, I'm going to select it. And as you get practiced at this, it becomes a bit easier to decide which one you're going to use. So I now know that my y equals 3. So this y right here equals 3. So now I'm going to write 4x plus 3 equals 11. I am now able to just solve that using my normal equation method, and I will get the value for x. So this is step 3 happening, and I'm going to write it to the side. I just want to resize that so I don't completely lose it. Okay, so step 3 is substitute your value for y, but it might be a different letter. So I don't really like to write 4y just in case it's a different letter and then you get confused. If you want to write it, please do. So substitute your value into the easiest looking equation and solve. And that is it. So let's solve this. 4x plus 3 equals 11. So plus 3 hops lands as minus 3. That's gone, leaving me 4x. 11 take 3 is 8. I'm going to divide through by the 4. So the x is on its own, and I can see that x is equal to 2. So the two values that I were looking for was, and I'm running out of space here, x is equal to 2 and y, which we found earlier, is equal to 3. Those are the solutions to my simultaneous equation. Now, I always find when you are first looking at the very first example, there is so much information coming out to you that it feels so much bigger and harder than it actually really is. You're stopping to make notes, you're going back, it doesn't flow, and therefore it feels like this is a huge question. Now, don't get me wrong, simultaneous equations is a big topic. It starts at grade 5. It is tricky. When we bring the negatives in next session, we're bringing in another level of thinking. But when we do this next example, I'm not going to be talking through all the steps. We're going to see it flow, hopefully, and then you'll get a better sense for how the method just builds and works through. All right. So here we go with our next question. We're going to do 2x plus 2y equals 10 and x plus 3y equals 7. So the first thing I have to do is get these to match. Now, actually, I only really need to multiply this one by 2. If I times that one by 2, I'm going to get that 2x, and I'm going to get that match. When I do my rewrite, I shall rewrite the top one, 2x plus 2y equals 10. And then I'm going to write 2x, 3y times 2 is 6y, 7 times 2 is 14. I'm then going to do my takeaway, showing it at every stage. That will be important later on, I promise you. So I've got 2 x's. I take away 2 x's. I've got nothing left. So that has gone. You could put a line in, but if you were comfortable with it, I would say just leave it blank, because then you haven't got anything interfering with what you're doing. I've got 2 and I need to take away 6. 2 take 6 is minus 4. So I've got minus 4y. 10 minus 14 is minus 4. So I've got minus 4y equaling minus 4. If I want to know what y equals, I'm going to get it on its own. So I'm going to pick up my times by minus 4. It will land as divide by minus 4. Y is now on its own because I've moved that. And it's going to equal, how many 4s in 4? 1. The 2 negatives make it positive. So my y is equal to 1. I'm then going to go back up here and choose one of these. It really doesn't make any difference. I'm just going to choose the top one. So I've got 2x plus 2y equaling 10. Now I know that y, from my previous piece of working out, I know that y is 1. I've got 2 times y here. So the number that's going to go in here is going to be 2 times whatever y is, which is 1. 2 times 1 is 2. So 2 is going to replace 2y. I've got my plus, I've got my 2x, and it equals 10. I now hop to get x on its own. So I'm going to take away that 2. That leaves me 2x because I've got rid of that. And 10 take 2 is 8. Divide through by 2, and x is equal to 4. And those are my 2 solutions. Y is equal to 1. X is equal to 4. So that is it in a nutshell, without all the extra conversation that we had through example 1. There's no shortcuts and there is a lot of steps, but every question is approached in the exact same way. So as you practice and get more familiar with the steps, it just naturally gets easier. All right. So I'm going to do another one. If you are at a stage where you're thinking, I'm doing all right, I'm following this, you might actually be ready to have a go. So I've got 3x plus y equaling 17, and I've got x plus 2y equaling 9. Okay, so if you're thinking, no, I've got my notes, I kind of get what's going on, I'm ready to have a go, please, please do. Just go as far as you can. If you get all the way to the end, brilliant. If you get halfway, you're doing half of it on your own. So whatever is good. If you're not quite ready, then wait. We'll go through this one and then you can have a go at the next one. Okay, so hit pause if you're having a go. Otherwise, I shall carry on. So I want to match this. I just need to times the bottom by 3. So rewrite the top one, 3x plus y equals 17. And then 3x, 2y times 3 is 6y. And 9 times 3 is 27. I'm going to take away, take away, take away. 3x, take 3x, gone. Happy days. I've got y. I've got 1y, and I'm going to take away 6 of them. So 1 take away 6 is minus 5y. We're just getting negatives every time, aren't we? It's probably a good thing because then they won't be so scary when they come round in the next session as well. 17 take away 27 is minus 10. Divide through by the minus 5 to get y on its own. 5s into 10 go 2, and the 2 negatives make it positive. Okay. I'm then going to go back and choose one of the 2. I'm going to choose the top one just because it's a single y, so it'll be really easy to substitute into. So I've got 3x plus y equaling 17. You may very well have chosen the other one. It makes no difference. It just means that your maths will be slightly different to my maths, but we will be getting the same answer out. I know that y is equal to 2, so that y there is 2. I've got 3x plus 2 equaling 17. And now I just solve it like a normal equation. So plus 2 lands as minus 2. That's gone, leaving me 3x on this side equaling 15. Divide through by the 3, and x is equal to 5. Okay. Now, if this is your first experience of the hopping method and you want to see that a little bit more, then go to the channel. There are some quick how-to help videos that shows this hopping method on lots of different types of equations, so you can familiarize yourself a little bit more with it if you've not seen it before. I use it absolutely everywhere. I use it for forming and solving equations, simultaneous equations. I use it for trigonometry, for Pythagoras, for anything with a formula. I use it for rearranging formula, as you saw in the first session. So it's a really fabulous method that we can just use all over the place. So being confident with our hopping method really does help with this topic as well. Okay, everybody, whether you've had a try or not, I want you now to pause with this new question. Okay, and I want you to have a go. Remember, that first step is all about matching the first 2. So what have you got to do to match the first 2? One of the other things that you could do if you're having a go at this and you're getting stuck at any stage is you could just press play up to the point that you needed to and then hit that pause. So you've had that little hint, that little bit to help you get going again, but you try and still finish it off without watching the whole thing. It's another way of using the video, okay? So press pause and hit play when you are ready. Okay, to get these to match, I'm going to have to do that cross multiplying that we saw in the very first example. So I'm going to be timesing the top one by 2 and the bottom one by 5. This is going to then give me 10x plus 4y equaling 42. And then timesing everything by the 5, I've got 10x, happy days. And then I've got plus 15y. And then 15 times 5 is 75. And then I do my takeaways, okay? Now, please don't feel like you have to be doing this all by hand. You can grab your calculator, okay? And you can do the maths that way. On the foundation paper, absolutely 100%. I have seen these so far to date on calculator papers. The calculator is not going to help you. You've got to learn the method to be able to get this right, but it can do some of the number work for you, which will make life a little bit easier. So 10x take 10x, they've gone. 4 take 15 is going to give me minus 11y. And then 42 take away 75 is going to give me minus 33. Now, if you'd done our little trick that we saw at the very beginning where we swapped them over, you wouldn't be seeing any of these negatives. It would all be coming out positive. However, I think, and that's why I'm doing it like this, we can't let the negatives get the better of us. So we just got to keep plugging away and use the calculator, like I say, to make it a little bit easier for you. Okay, I want to get y on its own. So my times by negative 11 is landing as divide. I've got y on its own. How many 11s in 33? 3, and the two negatives make it positive. So I've got y equals 3. I've then got to go and select one. I think I'll just go with the bottom one because the numbers are a little bit smaller. So I'm going to choose the bottom one this time. So I've got 2x plus 3y equals 15. So I'm using that original number. I know that my y is equal to 3. And I've got 3 of them there. I've got 3 times y going on there. So 3 times 3 is 9. So this 3y is turning into 9. I've still got the 2x and 15. Okay, so we are going to do take away 9. We want to get x on its own. So 15 take away 9 is 6. Divide through by the 2, and x is equal to 3. So they were both 3 in that example. All right. We'll do one more together and then I'm going to leave you to practice. Okay. So press, it's a tongue twister that. Press pause once you've got the question and have a go. All right. Try and get all the way to the end on this one because it's your last talk through before you have a go on your own anyway. Okay. So hit pause and play when you're ready. Okay, so I'm going to times the top one by 2 and the bottom one by 3 so that I can get my match. That's going to give me 6x plus 2y equaling 20 and 6x, 3 times 2 is 6, so plus 6y equaling 3 12s are 36. So I'm going to do take, take, take. The x's have gone. 2 take 6 is minus 4y. 20 take 36 is minus 16. Divide through by the minus 4 to get y on its own. 4s into 16 go 4 exactly. So y is equal to 4. Okay, I'm going to choose the top one. So I've got 3x plus y equaling 10. I know that my y is 4. So that y there is 4. And now I hop to work out the x. So that's going to land as minus 4. I've got 3x equaling 6. Divide through by that 3, and x is equal to 2. So if that went well, really, really good. It is a bit of practice makes perfect. I have deliberately done the questions so that they are coming out with negatives. They won't always, all right? I just want to do it so that you see it lots and lots of times. So if it happens, you're kind of ready for it. So you've got a whole load of questions to practice. The answers will follow. I really, really strongly recommend that you do a question, mark it. Do a question, mark it. If you've gone wrong, you've now got the answer for you to go back and go, right, what happened? Where did that mistake go wrong? Try and learn from it so you're ready for the next question. I'm going to disappear. I'm going to scroll through so that you can see all of them. If you're in your workbook, fine. And then I'll do the same with the answers, and you're just in control of pausing and then rewinding, etc., etc. And if you're joining me for session 3, we will be looking at simultaneous equations where we've got negatives here as well. And that there can cause a little bit of a hiccup sometimes. So we're going to look at ways of making sure we don't get muddled. And that will be the next session. All right. All right. Thank you for joining me with Simultaneous Equations, and hopefully I will see you next session.